All right, so for sure, like I said last week, and actually the week before that too, definitely you want those steps. You want that page and note with your steps right next to it all the time, because you want to get into a rhythm. Okay, you want to do the exact same thing every single problem. Okay. You're going to go through those steps, and there will be 8 total steps in the end. Okay. So far, we've got steps 1, 2, 3, 4, and 7 already. Wednesday, we'll get 2 more steps. We'll get step 1.5, and we'll get step 5. Okay. And then next week, Monday, we'll get step 6. But that's it. Okay. And then after next week, Monday, we are just going to literally work those steps all the way through until they become second nature to you. Okay? It's just how it is. Always get in that, do the exact same thing. Do the exact same thing. Do the exact same thing. The numbers may change, but the process so that you get to know it. Because the last class asked, well, are we going to do we get to use the note sheets, or do you want us to memorize the steps? No, I don't want you to do either one of them, because I want you to just be so ingrained in it that this is what I do, and then I do this, and then I do this, that you don't even need any of that stuff. Because you're not going to waste time with a note sheet on a test. Or you're not going to waste time thinking, okay, well, I think I need to do that. You're just going to know. And you're just going to know. Because it's 8 steps. We're going to do those 8 steps every single time on every single problem. Okay. So we'll start out with this one. Again, I know we should be on at least on our second page of pink graph paper. If you need more, always up here, ready for you, or come grab some if you need some. Okay. All right. So f of x equals 3 over x minus 2, when we need to find the asymptotal and end behaviors with it also. Okay? All right? So, step number 1 on our note sheet says we do what? So really it says we need to find the domain and the vertical asymptotes, but the process that we do is we set the denominator equal to 0. So in this particular case, I would set x minus 2 equal to 0, and then I would solve that, and that gets me x equals 2. Okay? From there now, what can I say based off of that? What is my domain? Okay. What else can I say based off of step number 1?
Vertical asymptote is x equals 2.
And how does a vertical asymptote go onto my graph? Dashed line. Okay. So it's a vertically dashed line. Okay. 2 to the right of the y-axis, in this case. Okay. So, for you, when you're putting your vertical axes or your horizontal axes or your next week slant asymptote, I should say asymptotes there, when you're putting those onto your graph, you want to make them be distinct. Okay? Now, if you compare the 2 different graphs that we have, your graph paper has the thick, solid axes and the thick, solid grid lines. Whereas if you look at your homework packet, those are the more transparent ones. On the tests from now on, it'll be the more transparent ones like that's on your homework packet. Okay? So, but for your notes, make sure you put it on there thick enough that you can see it. Okay? Fantastic. So that's step number 1. Step number 2 then says what? it should not just be Anthony talking right now. All of you have this stuff written down. Okay? Use your voices, ladies and gentlemen. This stuff's not going away. I hate to break it to you. Okay? So again, what is step number 2? Find the horizontal asymptote. How do I go about finding the horizontal asymptote? Compare what on the top and what on the bottom? The degrees. What's the degree? Not the exponent. The biggest exponent. Because like in the next example, we're going to have 2 exponents on the bottom. Okay? So we can't just say the exponent. That's the biggest. Okay? So what is the degree of the numerator? Biggest exponent on a variable in the top part of my fraction. 0, right? Okay? Because there is no variable in the numerator, so that gives me a degree of 0. Okay? Degree of the denominator. 1. Okay? So are we in a bigger on top, bigger on the bottom, or same case? Bigger on the bottom. So that tells me that my horizontal asymptote is what? Bigger on the bottom tells me horizontal asymptote is what? Y equals 0. Okay? If it were bigger on the top, what would be my horizontal asymptote? Nothing. None. Zilch, nada. Okay? If they were the same, what would my horizontal asymptote be? Y equals A over B? And how do I find A and B? The lead coefficients of the numerator and the lead coefficient of the denominator. Yep. Okay? Right? And again, that should all be on your note sheet. Okay? So this also becomes a dashed line that we put onto our graph because it's right along the x-axis. For sure, you definitely want to make that so that it's seeable. Okay. Love it. Next step. Step number 3. Okay. How do I find the y-intercept? Plug 0 into my function for x. So basically I find f of 0, which in this case is going to be 3 over 0 minus 2. That's going to be 3 over negative 2. So my y-intercept is going to be the point 0, comma, negative 3/2. Okay? Which, in terms of me writing the point down, I write it as negative 3/2 because that's exact. Okay? But in terms of me putting it on the graph, negative 3 divided by 2 is negative 1.5. So I'm going down 1.5 squares. So right there. Okay. Is that all for step 3? Okay. Step 4. How do I find the x-intercept? Set the numerator equal to 0. Can I get anything out of 3 equals 0? Yes? No? Maybe? Nope, because that's not a true statement. So what is my x-intercept then? What is my x-intercept then? Zero comma 0 would be the origin. And that would be an actual spot that it crosses then. It's none. Okay? Because it doesn't exist. So it's none. When I chose this example intentionally because I wanted people to say, well, it's 0 comma 0. Okay? But no, it's not. Because my numerator, 3 cannot equal 0, so there doesn't exist. No. There is no x-intercept in this particular project. Okay? Plus, if it was 0, 0, then it wouldn't be a function because I would be defined in 2 spots on the same vertical line test. Okay? All right. Step 7 now, right? Okay. What's step 7? T-charts, right? Okay. So on this side, I would probably go with positive 1. Oops. If I go with positive 1, then I get 3 over negative 1, which is negative 3. If I go with negative 10, I get 3 over negative 12, which is negative 1/4. That gives me 3 points on that side in that zone. I'm good with that. If I go with positive 3 for an x value, that gives me 3 over 1, which is 3. If I go with 4, I get 3 over 2. And if I go with 10, I'd get 3 over 8. Two, 4, 6, 8, 10, 3/8 is that. That allows me to now draw in my function. And that allows me to give my end and asymptotal behavior. So, end behavior. How do I start end behavior? As x goes to infinity. So what side of the graph are you talking about right now? Yep, so what side of the graph are you talking about? The right side? Yep, the right side. Okay. So as x on the right side of my graph is going to infinity, what's my function doing? What's my function doing on the right side of my graph?
Is it always going to be 0?
Not necessarily. What's the function doing on the right side of this graph? It's approaching 0 from above. Yep, because it's above the asymptote, right? And it's getting closer and closer to it. Matthew, yours, it always approaches the horizontal asymptote on end behavior. Okay? Right? So whatever the horizontal asymptote is. So sometimes it's 0, other times it could be 2 or 4, or whatever it is. Okay? Alright, so that's one of them. What's the other one? What was that? F of x goes to 0 from below. Yep. And on the left side of the graph, we're below the asymptote. Yep. Asymptotal behavior. As x is going to what? Somebody else.
From below,
Below?
above.
Above?
I don't know.
Well, it's vertical, right? Because my asymptote is vertical, right? So I can't really approach 2 from below or 2 from above. What do you got, Rod?
2 from the left.
2 from the left. Yep. Okay. So what's my function doing on the left side of my asymptote? It's going to negative infinity, turn down. Yeah. Then I've got the right side of that one. What's my function doing on the right side of that one? Somebody else. On positive infinity. So it turned up. Okay. And I only have those 2 for asymptotal behaviors because I only have 1 vertical asymptote. If I had a second vertical asymptote, then I'd have to do the left and the right side of that one. Or if I had a third one, I'd have to do 2 more left and right sides. Okay? However many vertical asymptotes we have, that's how many left and right sides we have to do for asymptotal behavior. Okay? All right. Try that one on your own. That's what I got for step number 1. Yeah. I get the degree on the numerator is 1, degree on the denominator is 2. So that's a bigger on the bottom case. So that's y equals 0 as my horizontal asymptote. I get a y-intercept of the origin. I get an x-intercept of the origin. Agree so far? Okay. So it was x over x squared minus x minus 2. So if I went -2, that's going to be -2 over. -2 squared is 4, minus -2 is 6, minus 2 is back to 4. -3 is going to be -3 over 9 minus -3 is 12, minus 2 is 10. And -10 is -10 over 100 minus -10 is 110, minus 2 is 108. So that's -1/2, that's -3/10, and that's pretty close to -1/10. So we're up in there. Then I've got my middle section. If I put in +1, I get 1 over 1 minus 1 minus 2 is -2. So that's -1/2. Oops, tap the brakes. Here we go again. Right in there. Okay. Now, I know it crosses or it touches the x-axis at the origin. From my Algebra 2 knowledge, since this purpleness right over here, since that wasn't a squared, it's not a double root, which means it's an actual crossing then. If it was a double root, if that was x squared equals 0, that's a double root and that becomes the kiss. It comes up, it kisses the axes, and then it goes back down, or it comes down, kisses, and goes back up. But because that's a singleton, it's a crossing. So that means that in this middle section, I'm going to be crossing over the x-axis right there. Okay? If you still need further proof of that, you would have to try something in the -1/2 range. Oops. And if I put in something in the -1/2 range, then that's going to be -1/2 divided by -1/2 squared is +1/4, minus -1/2 is +3/4, minus 2 is -1 1/4. Don't really even care about what the numbers are. I just care about the fact that it's a negative divided by a negative, which is a positive. Okay? And then we've got the third section, which is going to be 3 and 4 and 10. If I put 3 in there, I get 3 over 9 minus 3 minus 2, that's 4. If I put 4 in there, I get 4 over 16 minus 4 minus 2, which is 10. And if I put 10 in there, I get 10 over 100 minus 10 minus 2, which is 88. So that's here, and there. Then I asked to find end and asymptotal behavior to go along with this one. So my end behavior as x goes to infinity, my function is approaching 0 from above. As x goes to negative infinity, my function is approaching 0 from below. as x is approaching -1 from the left, my function is going down, so that's negative infinity. As it's approaching -1 from the right, my function is now going up. As x is approaching +2 now from the left, my function is going down. And as x approaches 2 from the right, my function is going up. Questions on any of those? Graph that one. Agree with my domain and my vertical asymptote. Denominator can never be 0 because we're adding 5. And imaginary numbers are not part of the real number system, so there's no restrictions, which means there's no vertical asymptotes. Degree of the top is 2, degree of the bottom is 2. Those are the same, so I get y equals 2 as my horizontal asymptote. Do we agree with that one? I get a y-intercept of 0, -2. Agree with that one? Agree with plus and minus the square root of 5 if I solve the numerator or set the numerator equal to 0, which gives me then 2 x-intercepts, one at the square root of 5, 0, and the other at negative square root of 5, 0. Square root of 5 is just a little bit bigger than 2. So that's kind of in there, and then be a little bit smaller than -2, kind of in there. Okay. So my graph looks like that. Because it's got to approach the asymptotes at the extremes, so the left and right side has to get closer and closer to the horizontal asymptote. Makes a little dip at the at the y-axis. And that's that. We wouldn't have any asymptotal behavior in this one. It didn't ask for it, but we wouldn't have any because we didn't have a vertical asymptote. And we would say that as x, if it was an end behavior type thing, again, it didn't ask for it, but if it was, we would then again say as x approaches positive infinity, our function is approaching 2 from below. And as x approaches negative infinity, our function is approaching 2 from below. Okay. Questions on that?
So for like a problem like this, all we do is get back out of y-intercept then?
I mean, you still got to do all the other stuff, but that's how we get to see that there is just a dip at the y-intercept or the y-axis. Again, I remind you, tomorrow you have a formative assessment in the Math Resource Center. Friday you have a quiz. This one's a little longer, just because there's more stuff to do. I think it's the exact same amount of problems. I think it's two graphs again. But there's more stuff to do now because tomorrow we're going to add in, or not tomorrow, Wednesday we'll add in holes. So there's more stuff to do with that. Okay? And then your homework, your yellow homework packet is also due on Friday. Okay? Okay? That's all I got for you today.